Hi everybody, time to talk about rational roots. I'm not sure you can read this, but I'm going to read as much as I can to you. So, section 4 of chapter 11 of your book is about rational roots. Any equation can have lots of different kinds of roots. It can have a real or imaginary. It can have rational and irrational. So this section is not about the imaginary or complex roots, just the rational ones. So it tells us some of the ways that we can find them. And first, we find all the possible rational roots. We're going to learn how to make a list of all the possible rational roots, and then we test them all, which we already really know how to do. That was what the first few sections are about. So we use our synthetic division. You can use long division, but you don't have to for any of these problems. Like, it's possible to do all of these just using synthetic division. So first we find all the possible roots, then we test all the possible roots. It's simple, like the concept is easy, but it can take a really long time because the list can get long. So here's how we do it. We have any kind of little equation here. We know that this one has 4 roots because its highest power is 4. So we know there's 4 total, and we generate a list of all the possible. Again, remember, we're only listing all the possible rational roots. There still might be some irrational or some complex roots too. So what we do to make our list of rational roots is we find the number, the constant at the end. If it's in order, the constant is at the end. We find the constant no matter where it is. And we find all of its factors, every number that goes into 4. So 1, 2, and 4 are the numbers that go into 4. Then we find all the factors of the leading coefficient. If it's not in order, you need to find the one with the highest power and use that one. So our leading coefficient here is 3. So we find all the factors of 3. I did that order on purpose because then we're going to make some fractions out of these, all the possible fractions that we can make out of these. We have to use the positive and negative version of each one. And the 4 has to go on top. So the factors of the constant always go on top of the factors of the leading coefficient. So here my possible fractions are 1 over 1, 2 over 1, 4 over 1. 1 over 3, 2 over 3, 4 over 3. But then we also have to have the positive and negative of each one. So what we have here is 1, 2, 3, 4, 5, 6 plus the positive and negative of each. There are 12 possible rational roots. And then we just start testing them. So first I tested the 1 with my synthetic division. Remember that we take each of the coefficients and put them here. I've got 3 because that's the first coefficient up here. Then I have the negative 11. Then I have a 0 because there is no x to the second term. Then the 10. And then the negative 4. And the first number I'm going to test is positive 1. It really doesn't matter. You can go in whatever order you want to. You just have to try some stuff. So I tried the positive 1. I bring the 3 down. 3 times 1 is 3. So that goes here. Then I add. So negative 11 plus 3 is negative 8. Negative 8 times 1 is negative 8. I add and get negative 8. Negative 8 times 1 is negative 8. I add and get 2. 2 times 1 is 2. I add, and I don't get 0. Remember, if you get anything other than 0, that means it was not a factor. So 1 is not it. Move on and test the next thing. You can see that when I did my synthetic division this time with the same method, I won't make you watch me do it again, I got a 0 as my remainder, so this negative 1 is a factor. We found one. So from now on, instead of going back to 3, negative 11, 0, 10, negative 4, we're going to use this depressed equation. Depressed as in one smaller. So now I'm going to keep checking factors, but I'm going to do it with those numbers instead. So I came over here and I tried the 1/3. I can see pretty quickly that this is not going to come out to a whole number, so notice I quit. When I can tell it is not going to have a remainder of 0, I go ahead and stop early. I tried the 2. I thought it might have a chance, and I kept going, but it did not end up with a remainder of 0. And then I tried the 2/3 and found that, hooray, it is. So now I have 2 of the factors for this equation. Now, we want to find all the rest, and I know that it has 4 total. I've found 2, -1 and 2/3. You have choices now. You can choose to continue testing things until you have tested all 12 options. That's one choice. The better choice, because this will only test these 12 and it won't find any of the irrational, imaginary, or complex roots. The better choice is now to come to this depressed equation. Now that we've gotten it to only 3 numbers here, this is a quadratic equation. Because remember, this is going to be our constant, x to the first, x to the second. We go up a power each time. If we had written this as an equation, it would have been -4 as a constant plus 14x minus 14x squared plus 3x to the third. We can go up a power each time. Remember, that last one is your remainder. So this is a quadratic, and we know how to factor quadratics. So here I wrote out what's left. 3x squared minus 12x plus 6. Well, the first thing I'm always supposed to do is take out a GCF if I can. So I did. It didn't really solve it for me, and I couldn't see a way to factor it. I couldn't find anything that multiplied to 2 and added up to -4, so I put it into the quadratic formula, which, as a reminder, is -b, so that's the opposite of b, plus or minus the square root of b squared. Remember, that will always be positive because anything squared is positive, minus 4ac, all over 2 times a. I just wrote 2 because my a here is 1. I simplified it the best that I could, and I came up with 2 plus or minus the square root of 2. So my 4 factors are, my 4 roots, -1, 2/3, 2 plus the square root of 2 from here, and 2 minus the square root of 2. So these 2 I found by testing my list of possible roots, and these 2 I found by factoring what was left. So it's long. The only good news is that if your leading coefficient was 1, then you don't have to do all the possible factors, because what happens is all the factors of your leading coefficient are 1, so you end up with just the whole numbers. It's not really that good of news because the list can still be pretty long, but for this example, I generated my list. So I did all the factors of 28 over all the factors of 1, which is 1. So I have plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 7, plus and minus 14, and plus and minus 28. I know that I expect to find 3, but if I can find even 1, then my depressed equation will be something I can factor. So at least we don't have to try to do synthetic division with some fractions in there. That's a bit of hope. I tried, first of all, you can see I tried +1 and it didn't work. I tried -1 and it didn't work. I tried 2 and it didn't work, so I got sick of going in order. I tried -4, still didn't work. You can see again, I didn't even finish it. I just could tell it wasn't going to be a 0. So -7 did work. There's my exclamation point. Hooray! I found one of the factors, but again, I expect a total of 3. I could keep testing and hope that I find the other 2, but it's possible I won't, because the other 2 might be imaginary or complex. So I wrote this depressed equation: 4 plus no x's plus x squared, otherwise known as x squared plus 4. Do you see it doesn't have an x term? If you put this into the quadratic equation, you will find that you get positive and negative 2i. So those are my 3 factors: positive 2i, negative 2i, and -7. Again, the concept here is really simple. First, you list all the possible rational roots, test them until you get a quadratic. Once you get it down to a quadratic, then you can either factor it or put it into the quadratic equation. Remember that when you list your possible roots, it's the ones on the constant first. We don't really pay attention to the sign because we have to do the positive and negative of each one in the long run anyway. So first the constant, then the leading coefficient, and then we make all those possible fractions with constant on top, leading coefficient on the bottom. And then just check them for what feels like forever. Be sure to send me a message, an email. We can Google chat or do whatever we need to